In the immortal words of Jerry Seinfeld, what's the deal with Sonic games? Seriously though, I've talked about this before in my Sonic Heroes video, but it really shows the power of a great brand that Sega can keep releasing turd after turd, yet gamers are still interested in upcoming Sonic games. A lesser character would have never survived this many fatally bad products, and I have to wonder if Nintendo is pissed off. Like, we've spent almost 40 years releasing great games with our characters, and you guys are still paying attention to this ridiculous hedgehog?
You can't keep getting away with it!
Yes, we are, because every now and then the stars align and they release something that's truly a B+?
Not bad!
In fact, right around the time that Big Red Button was developing what would become the universally panned Sonic Boom Rise of Lyric, Sonic Team themselves were working on something completely different. It was a game called Sonic Runners for iOS and Android. Okay, yeah, it's a mobile game, and I'm sure plenty of people turned off the second I said that, but that's kind of a shame. Despite being mobile, many people fell in love with its music, visuals, and addictive gameplay. And while detractors may say Sega was just cashing in on the endless runner concept, if any franchise makes sense to cash in on it, it is Sonic. How many times have you heard people say speed and 2D platforming is where Sonic is at its best? That's not to say it's perfect though, it did suffer from a lot of mobile gameness, pop-up ads, in-app purchases, Facebook integration.
Smoking these meats, just set the charcoal up and you set the wood. I'm the meat chef.
But I get it, no one wants to pay for apps, so developers have to make their money somehow. And on a completely unrelated note, have you heard of this video's sponsor, Squarespace? Well, let me take a moment to tell you about them. Squarespace is the all-in-one platform for creating a beautiful and professional-looking website with no hassle. If you're looking to start a business, blog, online store, or really any kind of web presence, Squarespace is the easiest way to do it. They have hundreds of responsive templates to suit any need you may have, and you get a fantastic WYSIWYG editor that lets you do anything, no code required. But if you do like to code, you can also enter custom CSS and header code anywhere you want. I especially like running my online store on Squarespace because it means that all that delicate payment information is being handled by widely used and well-tested code, rather than something cobbled together by me at 2 AM. So if you're looking for a convenient and straightforward way to make a website, look no further than squarespace.com. They have a free trial that lets you check out all of their features, and when you're ready to launch, go to squarespace.com/MattKC to save 10% off your first purchase. And now back to Sonic Runners. So while I obviously sympathize with having to make an operation profitable, sadly none of it actually ended up helping in the end. By the end of 2015, Sega considered the game a financial failure and began working to sunset it. The service was shut down by July the following year, and since the game required a constant online connection, this effectively rendered it unplayable. Or did it? Thanks to a team of dedicated fans who reverse engineered, re-implemented, and open sourced the server, the game is now playable once again with just some basic binary hacking to point the game to a custom server rather than Sega's. With control over the server, the community could now not only keep the game running, but also provide some long overdue new content, since things like custom stages, characters, and events are all pulled from the server. Truly an impressive display of the community banding together to keep something they love alive. Unfortunately, it didn't take them long to realize that this wouldn't work forever. In order to really maintain the game long term, the community would need to be able to update the client as well. And barring some kind of catastrophic leak from Sega, this would probably have to be through some kind of reverse engineering. This is where I come in. For me, I was interested in what I'm always interested in: preservation, especially of development assets, and porting a cool game to PC. I also recognized that compared to most decomp projects, this one would be fairly straightforward. See, the majority of games, in fact software in general, is distributed as machine code, that is, either written or more commonly compiled to native instructions for your CPU. This is obviously the fastest way to run code on a computer, but it's also the most rigid and inflexible. For one, it's not portable. You can't just run machine code for one processor on another, at least without the intervention of an emulator to translate every single instruction. For another, machine code is much lower level than languages like C or C++, and the assembly generated often doesn't closely resemble the code that it was compiled from. Many people will say it's literally impossible to derive C or C++ source code from a compiled executable, often comparing it with trying to unbake a cake. And there is some truth to that. You'll never get exactly the same code that was given to the compiler, especially when it comes to comments, variable names, and function names that CPUs usually have no use for. However, you can look at a cake. You might have to look at it on a molecular level, but you can look at it closely and try a bunch of different things and eventually arrive at a recipe that achieves more or less the same result. And the same sort of thing can be done with machine code to get higher level code that can be recompiled. Despite its lack of readability, the assembly code is telling you exactly what it's doing. Getting it in another language is just a matter of replicating all of those instructions. It takes a lot of time, years in fact, often even with a team of people. A decompilation of Diablo reportedly took someone 3 years working unemployed to finish, and the Mario 64 and GTA 3 decompilations took at least 2 years even with a team of people behind it. But with enough time and commitment, it is very much possible. However, in the case of Sonic Runners, I wouldn't actually have to deal with any of what I just mentioned, because it was made in Unity. Unity is centered primarily around C#, a language that is much higher level than C or C++. In fact, C# is so high level that it generally isn't compiled to machine code at all. While the specification doesn't require this, C# almost always compiles to something called Common Intermediate Language. Basically, it's something a lot like machine code, but it's not specific to any hardware CPU. Instead, a runtime environment, something that was compiled to machine code, interprets and/or recompiles it into machine code in real time as you use it. This is actually pretty similar to emulation that I mentioned earlier, except that the intermediate language is a little more optimized for the purpose than instructions for random other CPUs are. And while this is obviously significantly slower than the code being native for the CPU out of the gate, it does address the 2 limitations I mentioned earlier. Namely that it's portable, it can run on anything as long as a C# interpreter is available, but also that it can much more closely resemble the source code it was compiled from. So closely, in fact, that CIL can generally be decompiled straight back to C# automatically. In fact, unlike developers of machine code, C# developers often have to explicitly use obfuscation techniques just to prevent their applications from being completely decompiled. As such, if we open up the Sonic Runners Android version, find the .NET DLLs, and run them through any CIL decompiler, we effectively get the full C# source tree intact, minus the comments of course. Job kinda done. But it turns out we were a little lucky here. Speaking of obfuscation techniques, Unity contains a build feature called IL2CPP. This does exactly what it says on the tin, converts intermediate language, i.e. compiled C# code, into C++, which can then be compiled to machine code. This means that not only will the resulting game run faster, it'll also be much harder for hackers like us to reverse engineer it. For a developer, it sounds great, and naturally Sega did opt to use it. However, back then, the feature was only available for iOS builds. That means that while we got full source code from the Android version in just a handful of clicks, we would not have been so lucky with the iOS version, or if the game had come out a couple years later when Unity made that option available for both. But let's not worry about that, we have our decomp, let's use it. Except this is actually only a fraction of what we really need. We're missing, well, all of the Unity assets. Thankfully, there are tools for extracting those from a compiled Unity project too. In fact, there's a tool called Utiny that can generate an entire Unity project from a built game. Once again, job done pretty much, except there was a problem. See, Sonic Runners was built with Unity 4, first released in 2012 and last updated in 2016. Today, this version is considered absolutely geriatric, and most tools like this simply don't support it. Utiny can only produce a project compatible with, at minimum, Unity 2017. Okay, that's only like 2 years later, that doesn't sound that bad, right? Except Sonic Runners also uses a number of APIs that were deprecated and then removed, and not just minor things either. Crucial parts of the infrastructure and communication between client and server relied on APIs that simply no longer existed in 2017. Trying to open it in 2017 threw literally thousands of compiler errors, and enough had changed between the versions that even though runners wouldn't have used any Unity features after Unity 4, Utiny's 2017 compliant output simply crashed Unity 4 when trying to open it. Wow, how helpful. So I needed to make a decision. Either figure out how to get this project opening in Unity 4, or find a way to upgrade the game code to work in newer versions. Both of these choices would require a lot of work, and I ultimately decided to go with the former approach. Mostly because I felt it would be easier to try and match the original game as closely as possible, than have to rewrite large portions of the code, hoping it would more or less achieve the same result. In retrospect, I'm not sure this was true, but it was the choice I made at the time. The first thing was to figure out why Unity 4 was crashing. Unity project files can be stored in 2 different ways, either as binary files that are small and efficient, but can't be edited outside of Unity and can't be merged by version control systems like Git, or as text-based YAML. The YAML feature was really lucky because it meant I could compare side by side what a native Unity 4 asset was supposed to look like versus what Utiny output. And what I found immediately was that the game objects were written quite differently. So I wrote a script to basically rewrite and downgrade all of the game object YAMLs throughout the entire project, and after all this, Unity would no longer crash trying to open the project. Well, at least that's something, but we were still far from it actually playing. Naturally, it wasn't just the game objects, there were a lot of these assets that needed similar treatment. Animation controllers, particle systems, texture metadata, collision flags, and more had been updated in ways that Unity 4 no longer understood. A few weeks in, I had more than 30 different scripts just for downgrading each of these assets throughout the project. And this is why I say it may not have been the easier approach. However, it was the most accurate, and eventually things started coming together, at least on the opening titles. But that was about it. As soon as you tried to start the game past the opening screen, it would throw an error about failing to find something called Unmanaged Process. What is this? Well, it's a machine code library. Yeah, it turns out the game isn't all C#. And because my PC obviously isn't running Android, it obviously can't run. In fact, we also had this problem with the audio at first. It too was a machine code library called Cryware, which is actually a very popular audio subsystem used on a lot of games, especially games developed in Japan. However, since you can just buy the Cryware plugin on the Unity Asset Store, it was very easy to acquire a PC build for it. Unmanaged Process, on the other hand, I had no idea what to make of that. The name didn't help. Unmanaged is just another word for machine code, so it's basically like calling your application. What kind of third-party library would do something like that? Well, no third-party library. Sega made this specifically for Sonic runners, and to get any further in the decomp, we'd have to figure out what it did. But there was a problem. I opened it up in both IDA and Ghidra, and they both couldn't seem to make much of it. In fact, almost all of the functions simply seemed to be empty. But I could see some kind of odd assembly code was written there. I wanted to take a look at this while it was running, so I set up an Android debugger and breakpointed one of the functions. And as I stepped through it, it became pretty clear what was going on. Remember how I mentioned obfuscation? This was hella obfuscated. It would do ridiculous things like do a bunch of math just to result in a memory address like 30 bytes ahead, push it onto the stack and then call return, which would jump straight to it. It did that constantly. For every one line of actual code, there were like 10 lines of random bullshit designed to throw you off the scent. This function you're looking at right now, after watching it for like 45 minutes, I realized this is literally all it does. Just this. Everything else is pure obfuscation. These instructions too literally do nothing of any value. I started to feel like a sucker watching this code because it was designed quite specifically to waste my time. Was I really gonna have to watch this shit jerk itself off for hours just to even get a clue of what it was doing? Well, the answer is no, because I soon figured out what it was doing without even having to look at the assembly code. The C# would give it some parameters and Unmanaged Process would spit back some random stream of bytes in base 64. Except they weren't actually random. We knew exactly what these were. The game communicates with the server through JSON, which is pretty standard stuff, but in an attempt to curb cheating, the JSON is AES encrypted. However, if you as a player could retrieve the encryption key, then you could just replicate the AES encryption yourself and bypass that security entirely. Too bad C# is so easy to decompile. Realizing this, Sega decided to move all their server communication, including JSON encoding and AES encryption, to a separate obfuscated machine code library. A library so secretive they couldn't even give it a real name. And that's what we're seeing in Unmanaged Process. So this has got to be pretty bad for us, right? A pretty crucial part of the game that Sega has actively worked to make difficult for us to figure out? Well, as it turns out, not really. See, we already had an open source server, which means we already had the decryption key. Therefore, any data that came out of Unmanaged Process we could just decrypt, look at, and re-implement ourselves. In fact, it was even easier than that. Clearly, Unmanaged Process was something that came later in the game's life, because a fully functional JSON encoder and AES encryptor was just sitting in the C# code ready to be used. All I had to do was update the old retired key it had to the current one and hook all the code up to make the same packets I was decrypting from Unmanaged Process. In theory, I actually could have written anything here since we now had full control over both the client and server communication. But I figured it made sense to replicate the original packets, and after getting all of them implemented, we can finally at least get to the main menus. Now wait, if I just re-implemented the stuff in C# after they specifically moved it to a separate library, haven't I just undone one of Sega's anti-cheat measures? Yes.
Don't worry about it.
But this actually doesn't make it any easier to cheat than it already was. Like I said, we already knew the encryption key, which was the main thing Unmanaged Process was trying to keep secret. Technically, everyone knew the encryption key because it's part of the open source server code. So the security provided by Unmanaged Process had already been broken years ago. It's in fact what made it so easy to do my re-implementation in the first place. Now, if the team wanted to set a new key on their official server and not publish it in the open source code, there would definitely be an argument for hiding it in an obfuscated library again. But I figured that would be part of later discussions about the best ways to do anti-cheat in this day and age rather than several years ago, and that for now the highest priority was progressing further in the decomp. And progress it did! Not only did the main menus work, we could also now start getting in-game. Sort of. Enter yet another roadblock, Unity shaders. In theory, Unity shaders are portable by design. They're written in a slight variant of HLSL, which is Direct3D's shader language, but they use an in-house cross-compiler called HLSLCC to support shaders for OpenGL, Metal, and Vulkan as well. However, this cross-compilation actually happens at build time rather than runtime. This means that when you build a Unity project to Android, the shaders get cross-compiled to GLSL, and only those are packed into the final Android build. So what we were given are GLSL shaders that the Unity editor doesn't seem to know what to do with. Weirdly, while it has an option to run in forced OpenGL mode, that still doesn't seem to get the GLSL shaders working. Realistically though, even if they could be made to work, OpenGL is slowly but surely on its way out. So it just made sense to try getting these back into Unity's native format so they could be cross-compiled to everything else again. This was arguably the only part of this project that resembled real decompilation, manually rewriting every line of GLSL into Unity's variant of HLSL, and then adjusting it until we could confirm without a doubt that when Unity cross-compiled it back to GLSL for Android, it would be 100% identical again. A lot of these were actually really simple and took no more than 20 to 30 minutes each to decompile. But there were some big motherfuckers that I was absolutely dreading. One in particular I spent an entire day on and still didn't end up getting 100% matching GLSL, just to discover at the end that the shader was actually entirely generated from a handful of short Unity macros. That sucked, but I'm proud to say that eventually I did get every single one cross-compiling back to identical GLSL. So why doesn't it look right? It's obviously a huge improvement over when the shaders were completely broken, but if the shaders are mathematically producing identical code, why doesn't it look the same? Well, we had one last major roadblock, one last complicated issue that needed to be resolved. By now the game was playing pretty well, most things seemed to be working as expected, but it was hard to ignore how bad those backgrounds looked. One member of the team even attempted to rectify it by approximating the look with their own custom shader, but I knew it couldn't be shader related since I knew the GLSL was identical. There had to be something else we were missing. And there was, but it was something that took weeks to figure out. Let's talk about light maps. Lighting is actually really hard in 3D graphics, even without going into ray or path tracing. Having to figure out where 3D polygons are and aren't lit can be very computationally expensive, especially when your target is fairly underpowered phones. As such, it's common to do what's called baking, which I guess is our second cake metaphor for the day, where if you're not expecting your lighting to change in your scene, you can pre-calculate it beforehand, and then at runtime the game can just reuse that at all times. What results from that is a light map, which is exactly what it sounds like, a map of how everything is lit throughout the scene. The very next version of Unity, Unity 5, implemented a complete rewrite of the lighting system, including the light maps. In fact, while Unity 4 did have light map support, Sonic Runners didn't seem to actually be using it, instead passing its light maps into the custom shaders I just decompiled. Since they were manually being passed into the shaders, by all accounts it should have been working. Like I said, this took a long time to figure out. There was seemingly no obvious explanation for why light maps that we could clearly see, plugged into shaders we knew were identical, would not produce an identical result. I ended up playing around with all sorts of ideas, a lot of them just trying things at random, and eventually one of these random things actually happened to work. Looking through the YAML once again, I noticed this property called light map settings. At a glance it looks fine, or at least there doesn't seem to be anything wrong, but as kind of a Hail Mary I just decided to clear it entirely, thinking it might help to at least be able to set them up from scratch. But then it just worked? Yeah, removing the light map settings from every scene in the game fixed the issue everywhere. Why? I have no fucking idea. My only guess is that UTiny's output was just throwing off Unity 4 completely due to that rewritten lighting I mentioned earlier. All I knew for sure is that with this issue solved, the decomp was finally nearing a close. There are a few more minor issues here and there that I fixed up as the team got to start testing it, but for the most part it was ready for them to start making the additions that they had been waiting so long to do. And speaking of the team, I want to give them a big shout out because none of this would have been possible without them. I may have helped solve some big problems, but they're the reason that there's a revival project in the first place. They're the ones who love this game and are passionate about keeping it playable and up to date. All I did was see a really interesting project that could use my help and that they were happy for me to take a stab at. So go and show them some love and check out one of the more underappreciated Sonic games in recent memory. Not only does the game now have new features that Sega probably never even dreamed of, it's also free of ads, in-app purchases, and pestering Zuckerberg integration. You can even run the server on your phone and have a completely offline experience. So if anything, this is actually a better time to play it than when it was still supported by Sega. And last but not least, if this is the first time you're hearing of Sonic Runners, I recommend checking out the History of Sonic Runners video by PatMac. It's a much more thorough introduction to the game than this video is, and goes into a lot of detail about the ups and downs of the game's original run. But either way, as always, thanks for watching, I hope you enjoyed this video, and I'll see you all in the next one. Bye guys.